Alright guys, so today we're going to look at applying the power property rule to our exponents. Again, nothing new, but just kind of reinforcing what we've already learned and making sure that we have our exponents solid. You do have a quiz on Friday, so it would be good for us to really just a little bit more practice before our quiz. So the Common Core standard is a grade 8 standard with expressions and equations. We are working with radical and integer exponents, so it's EE. Oh, where'd that go? 7, 8 or 8, 1. And it's know and apply the properties of integer exponents to generate equivalent numerical expressions. For example, 3 squared times 3 to the negative 5th is 3 to the negative 3, which turns into a fraction, which is 1 over 27. So we're going to go ahead and solve some problems like this, or simplify them, in the next couple of pages, and then you will continue working on problems similar in class. So pause your video after I'm done here and write down your objective, and your heading for your video notes tonight should be power property. Okay, hopefully we press play and we're ready to continue. So I'm going to go ahead and turn to the next slide. I want you to take a couple of seconds and write these down. Give yourself some space to work them. And then put your pencil down because I want you to watch. Okay, so this is going to be an I do. I am going to do this one. And you are going to watch as I solve this problem. Okay, so here we have inside parentheses 4 to the third power. And we're multiplying that quantity to the second power. So whenever we are multiplying exponents, we are actually going to be multiplying our exponents. Now this is similar to when we have an exponent with the same base that we are multiplying. If you remember this from yesterday, when we are multiplying exponents with the same base, we are adding our exponents, right? 3 plus 2. But that's not what this is telling me to do. I am raising an exponent to a power. So this is not what we do when we are raising an exponent to a power. We are not multiplying same base exponents. We are raising a power to a power. So this is not what we do. In this instance, what we do is we take our base and our beginning exponent and we multiply that exponent by the exponent on the outside. So this becomes 4 to the 3 times 2, which becomes 4 to the 6th power. Okay? Now, in order to solve this, we would do our repeated addition. 4 times 4 times 4 times 4 times 4 times 4, and then find our solution. Today I only want you to simplify. If you look at the directions, it says simplify. So we're only simplifying it into a easier form of an exponential form. If you want to be brave and do the extension, you can, but I'm not going to require that of you tomorrow. Here I have 7 to the 4th power. Oh, before I do this one, go ahead and push pause and copy this down. Okay, so now that we're back, hopefully you've got this all copied down. We're going to look at this one here. This is 7 to the 4th power raised to the 3rd power. So what we're saying is 7 to the 4th power times 3. And this becomes 7, 4 times 3 is 12, to the 12th power. I don't need you to solve it at this point. I just need you to keep it simplified. This here is easier than looking at that. Okay, I'm going to go on, make sure you have this copied down. I'm going to go on to the next slide. So if you need to pause, pause. If not, let's continue. We'll go on to the next slide. I'm going to show you some special exponents here. Now there's a rule that you need to remember. Anything to the 0 power is what? I'm hoping you said 1. So I could work this out like I did the others. 3 to the 0, right? Or 2 to the 0. 2 times 0 is 0, becomes 3 to the 0, which is equal to 1. Or I could just say anything raised to the 0 power is going to be 1. If you show the work, that's fine. It really tells me that you understand what you're doing, and I like that. If you know that it's 1, that's okay too. So here I have a negative exponent, so this goes a little differently, right? So this is going to be 5 to the negative 4 times 3, right? So a negative times a positive is going to give me a negative exponent. So this is going to be negative 12, right? 4 times 3 is 12. We just did that. But I can't have a negative exponent, right? So that's going to end up becoming a fraction, 5 to the 12th. I don't need you to solve this right now. If you just give me this 1 over 5 to the 12th in a positive exponent, I'd be okay with that. Now something I want you to pay attention to is if you have, let's say you have a fraction in here that is raised to the 3rd power, you need to make sure that we are attaching this to this, right? So what this tells me, if I was to do this as a repeated multiplication, I would be doing this, right? So this is actually going to be 1 to the 3 times 2 over 6, which equals 1, 6 raised to the 6th power. And then there'd be 3 more of these. Okay, that's not one of your examples or homework, but in case you get it on a quiz, I want you to have an example written down in your notes on how to do it. It might be something that you want to add to a note card that helps you understand what you're doing here. Go ahead and push pause if you need to make sure you have everything written down inside your notes. If not, we're going to continue on to the last slide. Oh my, it says you do. Okay, this one you guys are going to do. You're going to solve it or simplify it and come up with your answer, and then we'll check your answers. This is your exit ticket. So this is my way of knowing that you guys actually watched the videos. Okay, so go ahead and solve this one. Push pause, copy the problem down, and then we'll check your answer tomorrow.